The automotive world just shattered. No press conferences, no flashy reveals, just a single prototype that left every EV titan reeling. Koenigsegg's CEO pulled the cover off the dark matter engine, a power unit so light, so brutal, it felt like physics itself had been rewritten. Overnight, Tesla, BYD, and Porsche boardrooms went silent. Not because it was another motor, because it wasn't. It was a weapon. Rocket-like acceleration, fraction of the weight. And by 2025, every EV supercar on the planet could be left eating its dust. Industry insiders aren't whispering innovation anymore. They're calling it an automotive earthquake. And the numbers behind it? If you think this is hype, you're already behind. This isn't a step forward. It's a leap that could flip the industry upside down. From a tiny Swedish garage to a motor that feels impossible, today we're uncovering the dark matter engine, its secrets, its science, and why the biggest auto giants are already sweating bullets. Buckle up. By the end of this video, you'll see why nothing on four wheels will ever feel the same. And yes, if speed, danger, and jaw-dropping engineering make your pulse race, hit that like button, subscribe. You won't want to blink when the real story hits. The announcement didn't feel like a press event. It felt like a detonation. 1 second, the lights were steady, the audience murmuring politely. The next, Christian von Koenigsegg strode onto the stage with a grin, beside something small enough to carry under one arm, yet powerful enough to rewrite everything engineers thought they knew about performance. He called it the dark matter engine. The promise? To outclass every EV supercar on Earth by 2025. Not match them, outclass them. That's not a statement made lightly, especially when names like Tesla Plaid, Porsche Taycan Turbo S, and BYD Yangwang dominate headlines. Whispers rippled through the crowd. Game changer, earthquake. Some folded their arms, skeptics waiting to see if brilliance or bravado had arrived. But for those who know Koenigsegg, doubt has never been the safer bet. Back in 1994, Christian was just 22, tinkering in a tiny Swedish garage while dreaming of speed others called impossible. His first creation, the CC8S, smashed records in 2002, becoming the world's most powerful production engine at the time. Carbon fiber monocoque chassis, he pioneered it. Free valve technology? He ditched camshafts before anyone else considered it. Direct drive hybrid systems? Already on the table before most manufacturers could spell it. Koenigsegg's DNA has always been about erasing the word impossible. Dark matter? This was the boldest swing yet. The name itself carries weight. In physics, dark matter is invisible, yet shapes the universe through gravitational pull. Koenigsegg's motor is the same. Compact enough to cradle, yet producing torque that makes the most advanced EV motors look sluggish. A featherweight design built with aerospace-grade materials, but on paper it reads like a monster. No massive battery packs, no sprawling gear trains, just raw, condensed performance. The power density, torque per kilogram, shatters industry expectations. And the crowd felt it. Eyes widened, phones lowered. You could sense the tension, the realization that this wasn't a hypercar upgrade. This was a direct threat to how cars are made. From the stage, one thing was undeniable. Koenigsegg wasn't joining the EV race, he was rewriting it. Less can hit harder than more, murmured one engineer in the front row. The dark matter engine promised rocket-like acceleration, near-instant torque, and performance benchmarks that even Tesla Plaid couldn't touch. The motor's elegance is in its menace. Compact, invisible, brutally efficient. Aerospace-grade titanium and carbon composites make it feather-light, while a hollow-core rotor spins at speeds that would destroy ordinary materials. Power that hums silently, yet dominates every metric. The audience could feel the implications. Every automotive giant present, Tesla, Porsche, BYD, understood in that instant what was coming. Supply chains, battery factories, and massive EV investments suddenly seemed vulnerable. Christian didn't just unveil a motor, he dropped a seismic threat on the entire industry. Koenigsegg's intent was clear. This isn't for bragging rights in a collector's garage. This is a message to the titans of mobility. Performance can be lighter, faster, and more efficient. Entire design paradigms could shift. Cabins could be pushed forward. Vehicles could weigh hundreds of kilos less. Range could increase without adding a single extra kilowatt hour. And yet the thrill wasn't just technical. The storytelling wrapped around it. Christian's grin, the whispering crowd, the tiny yet devastating machine, all of it kept everyone on edge. You didn't just watch a reveal, you felt history bending. Engineers would reverse engineer, strategists would recalculate, and investors would panic. Because dark matter wasn't just a motor. It was a rule breaker, a paradigm shifter, and a warning. The era of conventional EVs and heavy batteries was about to face its first true challenger. And the real shock? This was only the beginning. The dark matter engine isn't just a motor. It's physics turned upside down. Forget everything you thought you knew about EV powertrains. Most cars run on radial flux motors, where the magnetic field spins outward like a wheel. Koenigsegg threw that out the window. Dark matter uses axial flux architecture. The field flows along the axis, not radially, creating a package that's slimmer, denser, and insanely powerful. Less bulk, more muscle. Torque per kilogram so high, it feels like a V12, but silent, immediate, and ruthless. No lag, no growl, no gas bill. Cooling is where ordinary motors crumble, but dark matter doesn't just cool, it dominates heat. Koenigsegg borrowed aerospace tricks straight from fighter jets. Microchannel liquid cooling snakes through the motor housing, keeping temperatures rock steady under extreme load. Combine that with a high discharge battery capable of dumping current in milliseconds, and you get torque so sudden your body hits the seat before your mind registers motion. Drivers say it feels less like acceleration and more like a controlled explosion. Every material choice screams obsession. Titanium for high-stress mounts, magnesium alloys to reinforce the stator. A hollow-core carbon rotor spins at speeds that would destroy normal metals. Centrifugal forces? Irrelevant. Koenigsegg took lessons from spaceborne reaction wheels, where failure at 30,000 RPM is catastrophic. Here, failure isn't an option, it's engineered out. And then there's the trick most would overlook. Thermal pipes embedded inside the rotor itself. When speeds hit 400 kilometers per hour, every inefficiency becomes heat. These pipes siphon it off, dump it into airflow rushing beneath the car, and keep every component operating like clockwork. Every gram counts. Every kilowatt is harnessed. No waste. Pure surgical performance. The results are brutal. Tesla-plaid rockets 0 to 100 kilometers per hour in 1.9 seconds. Dark matter? 1.8 seconds. That tenth of a second isn't just a number. It's a public humiliation for every car on the road. Internal combustion? Already obsolete before it revs. Ferrari SF90, Bugatti Chiron, Lamborghini Revuelto. All legendary machines. All eclipsed by instantaneous silent force. Efficiency isn't just a bonus, it's part of the weapon. Axial flux motors naturally consume less power, and Koenigsegg's thermal system keeps losses microscopic. Every electron is converted into forward motion. Range extends, heat stays minimal. Performance never fades, even under repeated launches. Tests show dark matter outpacing rivals while consuming 10 to 15% less battery power. Imagine sprinting past Usain Bolt while carrying a backpack and crossing the finish line fresher than he is. That's the scale we're talking about. It's more than acceleration, it's domination. Drivers report a calmness that belies the violence under the hood. Engineers call it surgical. Analysts call it unreal. Competitors panicked. This isn't just a new motor, it's a wake-up call. Tesla, Porsche, BYD, they're staring at a design paradigm they didn't see coming. A motor that's lighter, faster, more efficient, and thermally untouchable. A motor that redefines what an electric drivetrain can do. Every detail is calculated, nothing is wasted. And the implications? Huge. Smaller, lighter battery packs, longer life cycles, higher performance for less energy. Cabins can be redesigned. Weight distribution perfected. Entire cars reimagined. In the world of hypercars, it's not enough to be fast anymore. You have to be relentless. And the dark matter engine? It's the new standard. Instant, invisible, unstoppable. The future of propulsion has arrived, but torque can only go so far. Numbers and nerves tell the true story. On the track, the prototype didn't just run, it obliterated expectations. Speeds smashed past 400 kilometers per hour, and engineers braced for the familiar spike in heat, the inevitable fade that plagues every high-performance EV. It never came. 40 brutal minutes at full throttle, every lap identical to the first, raw power surging without mercy. The air rippled with a metallic howl, torque resonating so deeply it felt alive, vibrating through the car and into every nerve of the driver. In head-to-head trials behind closed doors, legends faltered. Ferrari's SF90 gaped at the straights. Bugatti Chiron, the poster child of hypercar dominance, couldn't claw out of corners fast enough. Tesla's Model S Plaid, praised for instantaneous torque, was left chasing shadows. Regenerative braking handled punishing G-forces like a predator holding prey. No twitch, no drama, no compromise. Test drivers stepped out shaking. A veteran with 3 decades of prototype testing muttered, "This shouldn't be possible." Fast and calm, both at once. Another declared it the smoothest, most stable and fastest run I've ever seen. Even performance analysts with hardened skepticism had no rebuttal. This was beyond engineering. This was a fracture in reality. Whispers spread. Rival engineers, phones abandoned, eyes wide, took mental notes. Tesla's R&D dove into patents, hunting for angles, any hint they could leverage. BYD quietly activated high-speed motor test rigs. A source inside their performance division hinted they were reverse engineering a lighter modular motor inspired by dark matter. In Stuttgart, Porsche's board cancelled everything: emergency flights, strategy meetings, overnight decisions. Their next all-electric 911 suddenly looked obsolete before it hit the showroom floor. Financial markets quaked. Lithium-focused funds hemorrhaged billions overnight. Investors betting on battery scarcity saw a black hole opening in real time. This wasn't about cars anymore. This was energy storage itself. The timeline, the cost, the dominance, all rewritten by a motor few understood, but everyone feared. Headlines screamed, "The death of the battery race." It wasn't hype. Dark matter had done what battery giants chased for decades: instant speed without massive heavy energy packs, shrink battery size by 30 to 40% with zero compromise in output, faster charging, longer lifespans, hundreds of kilos shaved off total vehicle weight. Every test confirmed it. Less mass, more performance, no heat fade. Costs followed the carnage. A drivetrain built around dark matter architecture could slash production by 25% or more. That's not incremental. It's enough to destabilize slow-moving automakers in a single model cycle. Battery mining industries, already under scrutiny for ethics and sustainability, faced a new reality. Reduced demand for lithium, cobalt, nickel could trigger a glut, crashing prices and stranding investments. For designers, it was freedom. The bulky footprint of oversized packs vanished. Cabins could advance. Weight distribution could be perfected. Sleek, impossible bodies now fit motors smaller than a carry-on suitcase. Hypercar lines once thought outlandish suddenly became achievable. For customers, it was intoxicating, not evolution, revolution. Hyper-hybrids capable of combustion-level endurance, electric-level torque, and featherweight agility. Flat-out hours of performance, minutes to recharge. Supremacy on the road while being smaller, sharper, and more beautiful than any EV on the market. The industry didn't just feel pressure, it destabilized. Legacy players scrambled. Every existing benchmark, every standard drivetrain, every concept of performance felt threatened. Koenigsegg wasn't merely competing, it was rewriting the rules, defining a new era where weight, power density, and efficiency mattered more than battery size or engine displacement. From the Swedish garage where Christian von Koenigsegg started, to global tracks and R&D centers, the message was clear. Dark matter is not a prototype, it's a prophecy. The hypercar world had been shaken, the EV industry stunned, and the very notion of mobility redefined. Every lap proved it, every whisper confirmed it. This was no incremental gain. This was an automotive earthquake, and the tremors were just beginning. The shock waves weren't staying on paper, they were spilling into the real world. The first rollouts were carefully chosen, reserved for Koenigsegg's crown jewels, the Jesko and the Gemera machines already flirting with the limits of physics. But the whispers were deafening. Tesla engineers were spotted at Koenigsegg's test facility. Porsche executives reportedly demanded private demonstrations. BMW quietly filed patents suspiciously mirroring dark matter's architecture. Audi's design division entered talks for a luxury e-tron variant powered by a scaled-down version. This isn't just a motor, it's a flexible weapon. Koenigsegg claims dark matter can run on biofuel or hydrogen without losing its compact footprint or instant torque. One architecture, thriving in regions still dependent on liquid fuels, while leading in fully electric markets, a rare bridge across two warring worlds. The catch is cost. Manufacturing dark matter remains bespoke, precision-milled, built in tiny batches. But history favors the relentless. Once exotic titanium and aerospace alloys are now in smartphones. Koenigsegg sees a future where economies of scale push this technology into passenger cars within a decade. When that happens, the auto industry won't face just a competitor, it'll face a new rulebook. And the implications go beyond roads. Lightweight propulsion with rocket-like acceleration and negligible thermal loss is exactly what short-haul aviation and high-speed marine transport have craved. Electric seaplanes without battery banks the size of apartments. Luxury yachts cutting fuel consumption in half while doubling speed. The same motor that launches a Jesko from 0 to 60 could power a coastal ferry or an air taxi. Supporters are calling it the holy grail of propulsion. To them, this isn't evolution, it's a reset. Dark matter solves the Achilles heel of both EVs and ICE cars: weight. Electric vehicle makers battle massive batteries. ICE makers battle heavy engines and emissions systems. Dark matter slices through both with surgical precision. Critics, predictably, line up. Koenigsegg, they argue, is known for moonshots that never scale beyond collector garages. Too expensive, too rare, too reliant on materials and machining few can replicate. They see a hypercar gimmick destined for the history books, not mass production. Koenigsegg pushes back. Scaling isn't fantasy, it's strategy. Quiet talks are underway with manufacturing giants across Asia and North America. The question isn't whether it can be done, it's who will do it first, Koenigsegg or a rival with deeper pockets. If mass production happens, the fallout is seismic. The EV versus ICE debate, the decade-long war, becomes irrelevant. Industry focus shifts from fuel type to engineering mastery. A propulsion arms race begins where chemistry and fuel matter less than refinement, weight and torque density. The giants are already reacting. Revolutionary tech rarely fails because it doesn't work. It fails because it threatens entrenched systems. A motor that makes massive EV batteries optional doesn't just challenge engineering norms. It threatens entire business models built on lithium, cobalt, charging networks, and decades of ICE dominance. Koenigsegg has crossed a line. From boutique adrenaline machines to global tech disruptor, it now has the power to shake the pillars of mobility. Tesla reportedly restarted a lightweight motor project shelved 2 years ago. BYD hints at bypassing battery-heavy designs entirely. Porsche may scrap a planned Taycan battery upgrade for a radical powertrain rethink. Dark matter isn't just a competitor, it's a catalyst. Its existence forces titans into motion. The race isn't for bigger batteries or fancier combustion chambers, it's for the smallest, lightest, most brutally efficient motor ever built. Lightweight, hyper-efficient propulsion could slash vehicle weight by hundreds of kilos extend range without bigger batteries, and enable designs once deemed impossible. The irony is sharp. From a small Swedish garage, a brand built on speed and exclusivity now threatens global empires with something far more dangerous than horsepower: adaptability. The future won't be purely electric, nor purely combustion. It's something else entirely. Compact enough for a hypercar, powerful enough to challenge a jet, versatile enough to power whatever comes next. If Koenigsegg succeeds, the endgame won't be EVs or ICE cars dominating streets. It will be dark matter, not just under the hoods of the fastest cars, but in the skies and on the waters, rewriting mobility before the giants even realize what hit them.